Hi, my name is Christina, if you don't know me already. But I run a blog on Instagram called Chris Med Blog. I go to Iowa State. I graduate this fall. So I'm a senior. I'm a pre-med bio. What I'm looking to do with these blogs is just help pretty much pre-med students and also students who are taking these hard classes in the science field just to do tips and tricks, hopefully help you guys pass these classes, things that I've learned. I think I honestly learn best from other students who previously take these classes, and it's a struggle bus out here. So for today, I just wanted to go over some basic OChem things. So when you first get into OChem fresh, um, just some things that I wish that I kept in mind or just remembered, because they will haunt you into OChem too. So uh, pretty much if you go to Iowa State and are taking Chem 331, this would be the same class. I think I took it with Kraus. So he's a good professor, I would say. I also took it with Awino too. He's also was a really good professor as well. So if you have those professors, I do have notes and I can show you tips. So if you want to privately DM me as well, go right ahead. I will be more than willing to help with that. But so the first thing about what you want to know about OChem in general is that everything's the basic building blocks. So everything are made out of like different common elements, such as the carbon, hydrogens, oxygens, nitrogens. I feel like those are always been used from OChem 1 and OChem 2, and just something to just keep in mind of. Um, the most important element I would say would be definitely carbon, and it like links everything together pretty much. And to keep note that it has a charge of 4. So if we were going back to basic OCHEMs and you go to Iowa State, 177, 178, they definitely taught about charges, valence electrons, the shell. So carbon is located on the right-hand side of the periodic table. You can definitely count it. Hydrogen has 1, it goes 2, 3, 4, etc. Leaving carbon that has 4. So how carbon connects and links for OChem are some like these. And then cyclic alkynes kind of get more complicated, but definitely this is like the basic first structure and things that you learn about class, which is considered alkynes. So as you can see, each dot would represent a carbon, and these carbons link together. Now, going back to saying that it has 4 charges, this is because the charges count, and then there's invisible hydrogens. I know, crazy, right? But a carbon can attach to a carbon, and this bond from a carbon to a carbon is what considered is an alkyne. Now, say if there was a 2 carbons lines, so it would be doubled right here, then that would be called alkene. My primary pronunciation, but we consider it alkene because it's double bonded. But for right now, I'm going to show you what this looks like, because obviously if you're new to OChem, you wouldn't know what these squiggles are. So yes, they're carbons linked together in a long chain. So when I say carbon has 4 charges, it's because there's hydrogens attached to these carbon to make the full charge of 4. So if I have a carbon at this one end, that'd be considered 1, but I need 3 more to fill it up, this shell. So that's why we add hydrogens, because hydrogen has a count of 1, a positive count of 1. So when we add that, it will fill the shell of the carbon, making it 4. So that's why I added 3 there. So carbon would be 1, 2, 3, 4, and it fills it all up for carbon. Again, This one's attached right here. So this is attached to this carbon, so that's considered 1. This is attached to this carbon, is considered 2. And then we will have 2 hydrogens floating out, the invisible hydrogens, because normally when you do start out, yes, you can write it, but it does get a little messy when you start getting into more complicated forms. But once you get the hang of it, it will become simpler, and you can not have to write all of this down, and you just memorize it. But yep. So if we have a carbon here, the invisible carbon here, so it'd be 1, 2, and then to fill up the like valence electrons in the whole shell for 4, you would need 2 hydrogens here to fill up the whole shell of it. Yeah. So then this is like another example. It would be the same thing because there's 2 carbons between it. So it'd be 1, 2, 3. Yeah. 1, 2, 3, 4. So yes. And then this has a no. Yeah, hydrogen has a charge of 1. And again, carbon has a charge of 4. And then we'll get into these functional groups again. The basic ones you really just need to know is alkynes, alkenes, yeah, it's a complicated word, but all these like fun functional groups, definitely keep in mind of that. I definitely kind of do regret not memorizing the structures as well as I should. That's why I would say with OChem 1, definitely hone down on these and what they look like, because they will bite you. It will come and haunt you back in OChem 2 and all of your other classes. And what really sucks about OChem is that it does build off of each other. So if you can't get one topic down, then it would be harder to move on to the next. So keep that in mind. It's good to memorize these and their charges, and these little dots also represent the amount of charge, which I can get into another like video about, or if you learn it in class. But then we have prefixes, and prefixes are the beginning of how you name a compound. So how I remember it is how I remember it is called Mary Eats Peanut Butter, which sounds so like silly, but it does help. So Mary constitutes for methane that has only 1 carbon, and it looks like this, a stick. And then you go into the E, which is eat, ethane, yeah. And then it looks like a slanted line. And then you go into propane, which is the peanut butter part. And it just looks like an upside down peace sign. That's how I remember it. And then you have butane, which is butter. And it would look like this. And the structure, how I remember it, like counts for how many carbons there are on like the chain itself. So methane is 1, ethane is 2 carbons. Then you go into propane, which is 3, 4, which is butane, pentane, like a penthouse. That's how I think of it, which is weird. But if you also think of like as a pentagon too, so it has 5 carbons. And then you go to hexane, hexagon 6, 7, 8, 9, and 10. And you can see how the structure matches with how many carbons there are. So keep that in mind. So when you're drawing these structures out and they give you, say, like hept something, then you obviously know it needs 7 as its chain. So you're going to draw out 7, and then how I make sure I have 7 is to count the little like dots on the chain, pretty much. So 1, 2, 3, 4, 5, 6, 7. And then getting into naming it gets more complicated, but when you get the hang of it, it becomes easier. But for right now, how to set up a naming compounds is that you put the prefix first, and then you have the parent name, or considered what is called the parent chain, which is what I've showed you. That's considered the parent chain or the parent name. But the parent chain, so when you have more complex structures, not like a straight alkane, um, you'll need to find the longest chain on that structure, which will be considered the parent chain. Um, so that's how you name it. And then you obviously have the suffix from what we said in the beginning. Wow, did I just write it down? No, I didn't write it down. But the suffix is what is named afterwards. So alkanes, alkenes, all that fun jazz, but you're gonna end up using the end parts of the suffix. So if I have alkanes, it'll be ANES. Alkenes, which is the double carbon, would be alkenes. So it'd be just enes. So on and so forth. We're just gonna end up using the suffix depending on what structure as. Benzene will be most often look like a ring. And again, that has 4 attachments. Let's see. Yeah, but that is it.